Okay, I'm putting this video together just to kind of give an overview of some of the components and also how to build some of the circuits here, and to make sure that everyone's clear on this because some people haven't seen all of these components before. So this is the little component kit we got here. Oh, as a side note, this video at times might be a little jerky because I'm doing this on my Surface tablet here, and I might be moving it around to get different angles. So when you open it, you get a lot of different bins here with different things here. For this course, we want to keep, and I've already taken some of them out. This top one here has what are called potentiometers. These are variable resistors, and they're a little hard to read. I'll see if I can get this on the camera here. See if the camera will focus on it. Yeah, it does just fine. See, there's a B104 on that. So that refers to a resistance, that this potentiometer has a resistance of 10 times 10 to the fourth. So that would be 100,000 ohms or 100 kiloohms. So that's what this potentiometer is. You can also verify this by measuring the resistance on it. The resistance, if you want to see what kind of potentiometer it is, if you measure the resistance between these two contacts here, the top two contacts, that will give you what the resistance of the potentiometer is. Because then the variable part is this one right here. And literally what's happening, as I said, my camera might drop there. Literally what's happening with this device here is that, as I keep dropping it, when you adjust this little thing in here with like a screwdriver or something like that, what's happening is you're literally moving. There's a little arm here that you're kind of moving like in a circle and kind of basically changing the resistance. So that's a potentiometer. So that's the top left. The next one here are a bunch of capacitors. So let's go ahead and open one of these bags to kind of show you again how this is done here. Now again, we could actually measure these with our meter here. Let's see if we can get this to focus on the thing here. Yeah, it's having a hard time focusing on the actual value. But if you look at these here, there's a number written on these capacitors, and my eyes are having a hard time adjusting here. So this is 1.5, which I believe would just be 15 picofarads. Let me get another one out here so we can see here, because I don't know. Let's see what kind of capacitors we have here. Capacitors. Yeah, there is a 15. And then if I look at this one, the number here is 47, which would be 47 picofarads. Now let's pull out another bag of them here. There's another bag underneath here. And if I look at this bag here, one of the numbers on this, I'm just pulling one out here at random, is 471. So 471 stands for 47 times 10 to the first power picofarads. So, and yeah, it's not wanting to focus there. Oh, tiny bit. 471. So it's 47 times 10 to the first power. And so that would be 470 picofarads, or 0.47 nanofarads. Now, the disc capacitors, some of the capacitances are too small to read on our meter here, because if you look at the meter here, let me unwind my cables a little bit. If you look at the meter here, and we look down at the bottom here, well, it doesn't actually say on this one here. Sometimes they do here, but you can see it says capacitance right here. I'm sure it says on the data sheet somewhere or on the packaging that you received it in, which I've thrown out at this point. There's a limit to how small of a capacitor it can read. So the really small ones, like the picofarad capacitors, it's not going to read. Now, the reality is we're probably not going to use the picofarads too much. We're going to be in the higher capacitor ranges when we get to it. All right, and then moving on as far as the components go in here, this next bin is more capacitors. These are what are called Mylar capacitors. So let's open this up. Now what you might want to do, and this is completely up to you, because having them all loose and trying to dig through them can be somewhat challenging. Sometimes people just get another box, or they get little baggies that they put them in so that they can label the baggies with numbers, but that's completely up to you. So this one here has, well, this one actually has got 334 on it. It's actually 2A 334J. You kind of ignore the 2A and the J, and you want to look at the 334. And so these always start at 33 picofarads, but then 334 would be 33 times 10 to the 4th power, which if we look at our little kit here, that's actually going to correspond to the 0.33 microfarad capacitor. And then when they say 100 volts, basically what that means is they can take up to 100 volts across them. But Mylar capacitors, if we notice here on them, don't have any kind of indication of a positive or negative, and both leads are the same length. So Mylar capacitors don't matter what order you put them in. The same thing with the ceramics. Now we move on to the next bin here, and these are just more capacitors. So these are the electrolytic capacitors. Now these are the easiest ones to read because instead of having to do a computation, it's literally just looking at the capacitor itself. And let me get these out here. So for instance, I'll just pull out one of these bigger ones because it will be easier for the camera to see. You can see right there, it's 1,000 microfarads. Now this is what's kind of interesting. Yeah, it is 1,000 microfarad, 35 volt. Now this electrolytic, all the electrolytics have a positive and a negative side. So if we're ever using these in a circuit, we have to make sure that we put the positive in the correct side and the negative. And it's pretty obvious here. You can see there's just a big negative here. So this is the negative side. And another way to think about it is the longest lead. Notice how these are two different lengths. The longer lead's always the positive. But I think it's easiest just to look, well, hey, there's a simple negative here. So when we put those in a circuit, we have to be careful. Now, I'm not going to open this one here. These are diodes, and I think there's that's probably a photodetector in there. Some sort. We're not going to use them in circuits 1. We will be using these in, well, I said circuits 1, but electronics 1. We'll be using these in electronics 2 towards the end of the course. So I'm just going to put those back in for now and not doing. Now, as far as knowing what diodes they are, the frustrating thing is that there's tiny numbers written on them. So that's how you know which ones they are. It's kind of annoying. And I dropped my camera again here. Sorry about that. Then these next ones here are, again, these we're not going to touch this semester. These are transistors, and these are either NPN or PNP. And again, we'll learn about these in another course. Actually, I think it's it's in electronics 2 that you'll learn about these. These are very useful components. They were used, their initial use was in amplifiers. Now transistors are used for any kind of digital logic. So they're very useful components. Then down here, these two things here, let me read what these are. I think these might be diodes as well. I'd have to look up the part number. I don't use these very often. We're not going to use them here very often. They also might be transistors. These are other types of transistors, but these transistors are designed to have higher current going through them. And these actually might be also not just transistors. There might be like regulators in here, voltage regulators as well. But the reason they have this metal tab on them, or this hole in it, is so that you can actually mount a heat sink on them, because these will allow a much higher current through them. They have higher current ratings, but then they generate a lot of heat, so you got to put that heat somewhere. And so that's why we have these little metal tabs, and you can basically mount a heat sink on those. Moving on here, I don't know what this little gold thing is in there, but or gold looking thing there. But these are LEDs, so light emitting diodes. So they're actually the same kind of thing as this. These are diodes as well, and these are diodes. They're the same. They work the same way. It's just that these are used as a kind of circuit protection and other things of that nature, and these are used to actually, well, as the name would imply, generate light. But they're both diodes, so they both work the same way. Again, we'll look at those in future classes. These are inductors, and there is like a color band code, which we can look at. I put a little thing here, but on the bigger one, you can just see it says 33 millihenries on it. And then, of course, along in here is, some switches and buttons. I don't know if we'll actually use these too much, but you might use them in your capstone project when you create something. You might be using these in your capstone project. We probably won't use them in the lab too much. Then these are, of course, obviously just wires. They're designed to be able to fit into your breadboard. You also have red and blacks that I've already used when I was testing some of the circuits out that we're going to be building. You just use standard wire strippers on them. But you also have a package of breadboard wires that already have the nice little tips and everything. But you can still use this for whatever purpose you want. And now let me move something back here so I can shift it. This here are just alligator clip connectors and battery thing. Now the alligator clips, there's 4 of them. You might want to take the time. I haven't, but you could take the time, and this is just because it will make it easier sometimes. If you want to create, a cable that has a clip here, there's 2 ways. There's actually, you can crimp in here if you have a crimping tool, or you can even just use a pair of pliers where you put some wire in here and you fold it down. I would not use the breadboard wire. I'd use something slightly higher gauge on that. Or you can fold them down and put some solder there. This metal itself is not going to accept solder very well, so the best way is to either have a crimping tool or just use a pair of pliers to bend those down. And then you have to slide this back in, which is always frustrating to do, and I'm not going to spend time on the video showing you how to do that. But then what you can do is you can make your own little cables. So basically what you could do is you can make something like this, which goes into our signal generator, our audio generator, but then have the other end maybe, for instance, go into your power supply. It would just be bare wire, but just hook it into the power supply. So you have these nice alligator clips for your power supplies. Not necessary to do. I haven't done that for any of the things I've done. Here's just a speaker, of course, which we will probably use at some point here. When you use it, we will have to solder some wires on it, but it's important to notice there is a positive and negative side here. So you want to make sure to put in, I always typically just solder a red wire in here and then a black wire for positive and negative. And then this is a bunch of chips here, and I've taken them out, and some switches. These are 7-segment displays. Now, you just have to kind of look at what the numbers of these are here, because there's different numbers here, and depending on what the numbers are, tells us what the chip does, because we can look up the data sheet for the chip. We will use some of these chips. I can't remember precisely which one, but we will use them in the lab this semester, or this term, because they are some of these are just operational amplifiers. Then there's more chips that you'll use in a digital logic course. These are more digital logic chips that you'll use like 5 volts to power up. And then we come to the very last one here, and this bin here just contains all of your resistors. Now there's a lot of them, and I would highly suggest that you, because I have not done it and it's already becoming a mess here, is that you come up with a system to catalog these better. I mean, you could, you can look here on the thing here. You can see there's all these different values of resistors. You can make separate bags for all of those and put labels, or what you can do, sometimes people group them together where they'll do 10, 100, 1K, 10K, 100K all in the same bag, and then you just have to look at the last color band, or not the last one, the third color band, to see whether it's a 10 ohm, 100 ohm, or 100K, etc. And then they group the 470, the 4.7, the 47, in the 470K kind of thing. So that's one way to organize them, or you can just put them in little separate baggies. Now, I think I've posted the color code in our course for 1150, but if I haven't, I will make sure to post it there. So, for instance, this is brown, black, red, and so this would be 10 times 10 to the second power. So that would be 10 times 100, which is 1,000. So this would be a 1 kilo ohm resistor. And I'll just pop it out here to show you that this is a 1 kilo ohm resistor by then bringing in my little ohm, my DMM here. I got all the wires tangled up. Just give me a second. Okay, so let me see if I can get this so that it's going to show nicely on the computer screen. Okay, so I'm going to switch this to measuring resistance. And this is actually resistance and capacitance, and I'll show you maybe that in a second here. But if I touch the tabs here, and all I'm doing is connecting the ohm meter up to the two probes here. There we go. And I'm just holding it with my fingers. There's nothing dangerous about doing that. But we can see we get 0.979 kilo ohms, or 0.978. Looks like it's fluctuating between those two. And so, yes, it's 1 kilo ohm. We're never going to measure exactly 1 kilo ohm. But then again, even in your first lab, you're going to be looking at tolerances. And so, these all are 5% tolerances because their fourth band is, and I just realized on the video here, you can't see anything with that. So let me see if I can adjust this a little bit better here to make it a little bit clearer. Yeah, you can see now that I'm not measuring it exactly correct because I'm trying to hold it with one hand. And this is where I have the, and it's fluctuating because, again, my hands aren't very steady. All right, so that's, again, how we can measure the resistance. Now, if we wanted to measure, and that can help you organize your resistors. If you want to measure the capacitance, for instance, of a capacitor here, so I'm doing an electrolytic capacitor here. Now, we do have to measure this with the positive and negative side, but if I try to do it right now and put these in here to measure the capacitance, I'm not going to get anything. And what I'm going to get instead is a weird, like it's trying to measure some kind of resistance here. And it's like we're getting some kind of like weird value for, and that's because it's not in the mode for measuring capacitors. So we need to hit the mode button. Now you can see there's a little diode up here. And that's a little noise thing there. That noise thing, sorry, things started going in my ear here, something. The noise thing basically, and you might not be able to hear it through my mic, lets you tell if there's what's basically a short. I'm going to move a little bit closer. So that's literally me just touching the two probes together. Now that mode is actually extremely useful when you're debugging a circuit that's on like a PC board because you have all these traces and you're trying to see, well, are there good connections between all the components? And so you can literally just, touch different parts of the circuit and say, okay, these are supposed to be connected, and well, are they connected? Do I hear a beep? So that's another thing. But we want to measure capacitance, so I'm going to hit mode one more time, and now we can see that it says NF for nanofarads. And that's, again, to show you that we're not going to be able to measure some of these like small picofarad capacitors here. So if I put in here, let's see here, let it go. This actually might be too big of a capacitor. Yeah. So I put in trying to measure 1,000 microfarads, which is outside of its range. So let me get a smaller capacitor here. And measure this one. So I'm going to grab a smaller capacitor measure this one here. There we go. And that's measuring at 5.18 microfarads. And if I look at the value of this capacitor, the capacitor itself is 4.7 microfarad. Now, you might say that's pretty far off, but most capacitors, believe it or not, have tolerances of 25%. So you can get higher tolerance capacitors, but they're typically, pretty bad tolerances on them, just like standard electrolytics like we have in our kit here. All right, so that's kind of just an overview of the kit. I'll make one more video here kind of showing you a simple circuit to build, okay?